We're trying to prove something that seems just about like how in the world would you know that this constant 137 would pop out of thin air? Now this is an 8-digit number, ABCD juxtaposed, so it's 8 digits. And again, this D would be D times, D is just the units position, C times 10, B times 10 squared, A times 10 cubed, B times 10, D times 10 to the fourth, and so on. So this is just an 8-digit number, and I've seen the Vinculum / overline notation used to connote that a lot. I'm just going to leave that off as we proceed. Now we're trying to show, it is a base 10 numeral, we're trying to show that 137 is a divisor of this 8-digit number, and you're going, my God, how could that even happen? There's no structure here other than just this kind of symmetry here. So just to be clear on what we're trying to show, another way of stating this is that ABCD is actually a multiple of 137. So ABCD juxtaposed with ABCD. Okay, is equal to 137M. That's a little more explicit. You know, we're trying to find this sort of structure right here. Now, another way of stating it, if you like modular arithmetic, is that you could say that ABCD is congruent to 0 mod 37. It's a little more useful, I think, just to write it like this and proceed. So let's move along. Now, again, you just move along here by writing down some simple truths. You can rewrite our 8-digit number like this, ABCD with 4 trailing zeros plus ABCD. Simple but true fact, right? That's because ABCD times 10,000 is actually equal to this, right? In other words, I replace this with exactly what it's equal to, and this is understood multiplication right here of this 4-digit number with this 5-digit number, I guess. Okay, so now what we have right here, it all works out nicely because there's an understood 1 right here, right? Understood 1. Okay, and then when you add this 1 to this 1 right here, you get ABCD times 10,001. Okay, so we now see that all we have to do is show that 137 is a divisor of 10,001 to have completed the problem. Okay, so let's see if we can manage that. Third grade arithmetic, right, or even lower. So we have 137. Very few of us do this anymore, so bear with me. Okay, now, so we're trying to divide this into now, what I remember about it, you would start right here because it's this 5-digit number and this 3-digit number, so you would go to the tens position just to shift it over appropriately. And notice that 8 times 13 would be too big. That's already 1,024, right? So we give 7 a whirl. Okay, so we put 7 right here, and then we're going to multiply this 7 times this and see where the chips fall. And if you carefully multiply that out, you'll get 959, and then a 0 right here. Okay, again, we're in the tens position. Here's what I remember about this, okay? Now we have to just do a columnar subtract. It's clear that you get 1 in the last position. And you guys can see carries, or borrows happens over and over and over. This would become a 10 because you'd have to steal from here. So you would have a 1 right here also, right? Now you would have, this would become a 9 because you would have borrowed from here, right? And so you end up with, 411, right? Okay. Now, did I do that right? Yeah. I borrow. There's nothing left here, right? So we got 411 right here. Now we're hoping that 137, and it is, guys, look, 3 times 137 is 390 plus 21, which is 411. So you have 3 times, and you see we're getting another constant for free here because this would be 411, right? And we get a remainder of 0. And by the way, I could not teach this. You need a third grade teacher to teach this who has the patience and remembers it. I must have got this right because we got the remainder of 0 here. But anyway, so we get 2. We get the 137, and the problem just is we also have learned that 73 is another. These look like they're probably both prime numbers, right? But 73 and 137, so the problem just as well could have said 73 divides this, right? So you now know this about this type of number, okay? So we have proved what we set out to prove, since this number is equal to, let me just write it right up here just to save some time. This is equal to 137 times 73. And y'all, what I mean is just, this is sloppy here, but I mean just this number. Okay, just this circle part is what I'm talking about. Okay, again, kind of sloppy. But if this is a multiple of 137, so is the entire object ABCD. So it's QED time. Okay. Again, 10,001 is a multiple of 137, but ABCD is equal to another number times this multiple of 137. So that means that ABCD also has to be a multiple of 137 or 73, if that's what you want to do. So again, you may want to check it out. I won't try to do the calculations for you. I don't think I could really without wasting more time. But like this is saying that 4312 divided by 137 reduces to a natural number. Okay, you can check it out if you want. You just verify with a calculator, I guess, or do it by hand if you feel like it. But anyway, pretty cool problem, I thought, and it's a recreational math problem. I would call it that more than anything deep. But I would say I'm sure there's PhD mathematicians that wouldn't know how to start here right off the bat. You know, they're caught up in other things that are not this basic arithmetic stuff, and they may. I'm conjecturing that there would be a group of people who have PhDs in mathematics who, they never admit it, but you put them in a room without any resources, say, prove this, they may not know where to start. And I'm saying a lot of them probably would, the majority probably would, but some of them are so overtrained to think abstractly and about so-called deeper problems in this. Just to notice this, to me, was a little bit of a, like it's simple once you see it, but would you know to start? Because when you first see this, I think most of us would just be blindsided, like, what, really, why, But again, it's what I would call recreational math, because it's a super simple solution, but some of us may not have discovered that particular solution, which is, I think, the only solution. Okay, thanks for viewing.